Hi, everybody. My name is Gabriella Giordano. I'm a first-year master's student in the Department of Marine Sciences here at UGA, and I work in Amanda Spivak's lab. So we study coastal biogeochemistry. And my email is down here at the bottom. If you have any questions, want to comment on anything I say today, or just want to chat in general, I'd be happy to talk to any of you guys. Um, so a little background about me. I grew up in New York. I've lived there most of my life. The last 4 years, I was doing my undergrad at Villanova University in Pennsylvania, where I got a bachelor's in environmental science and geography. Graduated in a pandemic, go class of 2020. And while I was there, all 4 years, I worked in coastal salt marshes, and that's kind of where my love for marshes began, if you would say. And so this is me taking a sediment core. So here we looked at carbon dynamics as well as nutrient cycling through the system, accretion rates, sediment deposition, all sorts of different biogeochemical processes that happen in marshes. And for my senior thesis, I looked at metal concentrations in sediment and mussels across a salinity gradient in the system to see how the system is at filtering out nutrients, filtering out metals, and how that may affect the mussels and living organisms in the system. And so I'm hoping to get that published pretty soon. This is just another picture of marshes. This is up in Plum Island, Massachusetts. They're really beautiful and cool systems. You should come study them. And so then my next step was to come here to UGA to start my master's program. Still in a pandemic, but we're making the most of it. And I work with Amanda Spivak, like I mentioned, still looking at coastal biogeochemistry. But here we're focusing a little bit more on the carbon dynamics in the system and using isotopic analyses to look at those carbon sources and the fate of that carbon in the system. And so my project in the Spivak lab is looking at the Satilla River, which is this river down here on the coast of Georgia. We're really close to Florida, which is about right here. And so these marshes are a riverine system. It's a blackwater river, so it's high in organics. And essentially with sea level rise and saltwater intrusion, there's salt water moving further and further up these rivers. And the goal of this project is to look at different sites across the salinity gradient and look at how the carbon dynamics are changing across these sites with increasing salinity. Some of the sites up in the upper estuary are experiencing dieback or changes in vegetation and marsh type from fresher systems to more brackish, which is an intermediary salinity environment type, or even full estuarine sites. So what we do is we take these sediment cores and we've gotten a couple of these so far, but we're about to go out into the field and get some more. And they end up looking like this once we cut them in half for analyses. And one half of it goes to isotopic analyses to date the core, look at accretion rates and um, see how the marsh is growing over time. And the other half of this core is going to get analyzed for carbon content. So inorganic, organic, and then we're looking at different size fractions. And so we're trying to see how bioavailable that carbon is, what the sources of that carbon are, all sorts of fun things like that. So the major data deliverables for my project will be long-term accretion rates, looking at isotopic dating, like I just mentioned, over like 100-year time scale. And then I'm also looking at the organic carbon sources and the composition of that carbon. And this can tell us a lot about the past characteristics of the marsh and hopefully some of the future characteristics of that marsh and what's happening and where it could go. So the larger questions that we can answer from this research are whether marshes are keeping up with sea level rise, especially on the Georgia coast, and if the transition to a different marsh type has an impact on the way that carbon is buried, how much of that carbon remains in the soil, and how bioavailable that carbon is. So some other questions are what sources are contributing to marsh growth in each marsh type and how much of that is accumulating and what is the major form of carbon that is sustaining marsh growth and how stable is that. Um, I've also had the opportunity to work in the Georgia Coastal Ecosystems LTR, which is off of the coast of Sapelo. And so that is a site within the LTR network, which is a series of sites across the country funded by the National Science Foundation, where the goal is to accumulate long-term data sets of different environment types. So the Georgia coastal ecosystem is a marsh type. And I've been working with the Disturbance Project on that, looking at how rack depositions, which are patches of dead and decomposing plant material, how that affects the underlying marsh. And so there's a bunch of people working on that project. We're specifically looking at how that affects plant growth and then the biogeochemistry in the sediment, so decomposition, and salinity, pore water nutrients, all sorts of things like that. And so that's been a really great opportunity. I've been able to go into the field twice for that so far. And I'm hoping to get out there again soon. So yeah, if you have any questions about my research, about the SPVAC lab, or about the Department of Marine Sciences in general, please feel free to reach out. My email is was on the front of that slide there. It's gabriella.giordano@uga.edu. So I'd be happy to answer any questions or just chat. So yeah, thanks. Go Dogs.